Okay, recording. So welcome to the Harbor Committee meeting. Today is May 19th. I think we have one of our maintainers will go over, there's a proposal for bandwidth limit. I'll put the PR in chat right here. So who is gonna talk about this? Is it Dun Qian or is it Zining or whoever's sharing? Please just take it over.
I will share the bandwidth. As you know, there are some customer complaints that when they do some replication jobs, the network may be occupied, and their bandbound network may be slow and affect their business schedule. So in the future release, we want to add a new feature that help to limit the replication bandwidth. Here, I submit a simple proposal first. In this proposal, I want to add a speed limit when user added the replication rule. Here he can set a speed for one replication for the replication job, and this will limited limited the replication job to the speed. I mean, in here you can see when user set the speed of this replication job. For example, if user create a replication job with one job is one.
Yeah, one megabyte per second.
Yeah, so 1 megabyte per second for this core library job. It will download oh, sorry, this should be, oh, sorry. I mean, when user create a pool library job with 500 speed, it will download each repo with this speed. And here, for example, he has 2 repos, Redis and Postgres. So totally, it will use 1 megabytes per second, and he can also create another replication job with 1 megabyte per second. And if there are 3 repos, it will use up to 3 megabytes per second. And he can also create another push-based replication job with 1.5 millibytes per second. If there are three repos, it will use up to 4.5 millibytes per second. Also, it will still cost. It may still cost up to 7.5 millibytes per second in all, but still it can help user to control the network. The reason I propose this solution is because the implement is simple. In this proposal, we can just add a limit reader, just in this adapter field. When the code to pull the block, it will use this IO limit reader to control the speed. Here I propose use the library, which is from Golang org. Some official library. The code is just like this. It is quite simple, and it can control the speed of each job. I mean each replication, each repo in the replication. So here is the main proposal I propose here. I think if the community can have some better solution, like the library that can help to control the speed across the multi-thread, or maybe suggest some other library to help implement this reader. It will also be welcome. Okay, Alex, I'm done.
Thanks. Thanks, Timmy. Yeah, I have not taken a look at this yet, but I definitely will. Yeah, this seems very useful for Harbor on the edge, right? For Harbor deployments on the edge, usually the bandwidth is capped in some way. So, any other questions for Timmy for this proposal, or what this is trying to do? Okay, let's move on to the next one. So, Stephen, do you want to share something about the Harbor operator, which we just released, I think last week, Harbor operator 1.0?
Sure. Let me show my screen. Okay, can you guys see my screen?
Yep.
Okay, cool. So yeah, as Alex mentioned, the Harbor operator, 1.0.0 has been GA in early of May. And here I want to, recognize some, significant contributors who had did very important contributions in the 1.0 release. They are from, Pierre, Simon, and Jimmy, Max Hertrey from OVH team, and Wei Wei He and Ziming Zhang from VMware team, and Canfeng Wang from NetEase, and Ghost Baby, that's Hui Jun Zhu from Yunmama, and Xiaoyang Zhu from QingCloud, and Chen Yuzhang from Aloda Cloud, and Xavier is a free contributor. So a great thanks to those contributors who did a very significant contribution to this release. Okay, here I want to quickly, share some overview of the hub operator. Actually, the hub operator, provides a high ability for you to define and configure your, own harbor stack, based on your own needs. I think this diagram can, describe the overall, design of the hub operator. So there is a top level customer resource named Harbor Cluster. User can use this CR to define their, deploying on Harbor cluster stack. That means why we use the Harbor cluster as the CR, because Harbor is composed of multiple service components. Besides Harbor its own components, Harbor also depends on some a service like PostSeeker as database, and Redis as cache, and storage as something like Fersin or some S3 as its backend storage service. So the cluster means the whole stack will include the Harbor components as well as its dependent service. Okay, here because the cluster has a very flexibility for you to define your stack. For example, besides deploying the Harbor components like Harbor Core, Harbor Registry, Harbor Driver Service, you have very a strong flexibility to configure the dependent service. If you deploy some pre-deployed some service like a PCSQL service already service, you can directly configure your pre-installed service to this cluster. Of course, if you have some cloud service like RDS or some Redis as a service, then you can also create some endpoint and directly configure it into the Harbor cluster. That means from this, you can also configure some external or pre-installed service as the dependent service of the Harbor. Okay. Besides that, we also support, deploying some, those dependent service into the cluster together with the Harbor components. If you don't have some pre-installed service, or if you don't have some cloud service, so there will be some, other, other section for you to define such in-cluster service. For the in-cluster, for PostSeeker, we leverage the third-party, Zelado PCSeeker as our, a PCSeeker service vendor. We use a Redis failover operator as the Redis vendor, and we use the MiIO as the, as the S3 compatible backend storage service. So for using those third-party, you just need to define your requirements in the Harbor cluster part. It's a little different with the configuration, but you can define some requirements for the service. Then, Harbor operator will help you to connect it to the underlying operator to create some, service CRs and configure this service CR into Harbor as the corresponding backend configuration to make the Harbor work well. So that means you have very flexibility to configure your Harbor. For example, maybe you use RDS, that means the AWS P-SQL service as your backend database, but you can also use a MIL operator to create a MIL S3 backend service in the cluster, so they can mix not all external or all in class, right? Because you can configure the Harbor stack based on your real needs or based on your environment. So in a short words, you can configure external service. You can also deploy, the service together with the Harbor components into the cluster. Okay. Of course, here I want to mention in the 1.0, the service is exposed via the ingress. So you need to, install some ingress control like default NGX or GCE or NCP. Okay, and we leverage the cert manager to manage the related certificates. So for using the Harbor, cluster or the Harbor operator, you also need to install a cert manager controller. So this is the overall, the overall design of the Harbor operator. So in a summary, what features supported, besides, different, size of deploying Harbor stack, you can also, configure different backend storage. In 1.0, we support file system. That means in Kubernetes, you can directly use the PV as your backend storage. We support S3 and S3 compatible service like AWS, S3, and MIO. And we also support Swift as the backend storage. And besides creating the Harbor cluster, that means deploying a Harbor cluster, you can also update your cluster by changing some property of the spec. We also support you to configure different replicas of different components. Okay, and besides this, we also support in-place upgrades. That means you can upgrade the Harbor deployed by this operator. So if of course this is the first version, so there is no upgrading case. But in future, if there is some new Harbor version created, you can do the in-place upgrades process. Of course, we support Cascade Deletion. That means after you delete the Harbor cluster, all the link in the resource will be deleted. And besides the deployment, we also under the lifecycle management, we also support D2 operation. That means you can configure the Harbor system settings with the config map in a declarative way. That means you can create a config map to specify some system settings. This system setting can be applied to the deployed Harbor. Okay, that means it's a very easy way, a simple way for you to update the system setting of your deploying Harbor stack. Okay, and I just mentioned before, this time we expose the related service with the ingress. So far, we support a different ingress controller like NGX as the default one, and we also support the GCE from Google and the NCX NCP from the VMware NCX. Okay, this is the 1.0 feature, the features supported. Okay, so in what's next? And actually, short term next is we have planned a 1.01 patch to fix some bugs we have found. Besides fixing bug, we also support. We also want to make sure the Harbor operator can work well with the counter ingress controller. Counter is also a Kubernetes ingress controller and sponsored by originated from the VMware. Okay, for the long term, for the long term plan, here I list some key features we may introduce in the long term release. The first one is support more backend storage. Besides the current 3 file system, S3 and Swift, maybe we later will support more like Arrow, global storage, and the OSS and the GCS, the Google Cloud Storage back. And also will support remove the optional hardware components by directly updating the spec of the deployed hardware class. As you know, hardware has some mandatory component that must be deployed when deploy hardware, and has some optional or components like charter museum notary, and that's should be selected by yourself. So when you want to downgrade your full stack by removing some hardware components, you can just update the spec. So far, it does not support. Okay, and we also introduced a new service exposing way. Besides the ingress, we will support a load balancer as a new way to expose the related accessing service. And maybe in future we support backup and restore the data. We define some new CR to configure this process, and maybe auto scaling for the components. Besides, most of the related to the lifecycle management of the deployed hardware stack, we also considering to support more D2 operations. These D2 operations will be apply some operations to the deployed hardware to make you use the hardware in a very easy way, in a very simple way. Okay, I think the D2 operation might contain some the following items, like first we'll reflect the configure map based system setting configurations. We'll provide a CRD based. That means with the CRD we can define some system setting with strong types. That means it's very easy for validation. At present, I have mentioned the configure map based is supported. We'll replace the configure map with the new CRD based way for you to apply system settings to the deployed hardware. Okay, and we also support auto mapping approach for between the Kubernetes namespace and the hardware projects. That means if you set some special settings, when you create a Kubernetes namespace, there will be a corresponding hardware project created in your target hardware. And we also support like pull secrets auto injects. That means after you create your Kubernetes, there will be a hardware project create, and we'll also create some robot account in the target hardware project and bundle it to the service account for you to, so you do not need to take care of such configuration and directly start to use the image. Okay, we also support some container image path rewriting. That means you do not need to change your deployment manifest. You do not need to modify the image path in your deployment manifest. We will directly overwrite the path for you when you deploy your workloads to the cluster. Of course, that should be enabled by yourself. Okay, and based on the container image rewriting, we will support transparent per cache setting. That means we can provide a way for you to set a global per cache. That means for all the related namespace, in all the related Kubernetes namespace, their image path, for the workload deploy to that to those namespace, the image path can be automatically overwrite to the specified cache per cache project. So that for you to you do not need to configure it with a very complex way. We will provide some simple way for you to enable the proxy cache of Harbor in your Kubernetes namespace. So all the detail will help you to improve the user experience of using Harbor in the Kubernetes. We'll let the user use the Harbor with a smooth and a simple way. So this is the goal of the D2 operation. And actually for the D2 operation functionality, we have done some prototype in a POC project. So if you have interest, you can navigate to that project to learn more. Okay. So and for the long-term planning, we have created the 1.1 and the 1.2 release plan. If you want to learn more, what will be introduced in the next releases, you can check those two different plan items. Okay, so that's something about the new Harbor operator. So we will continue to improve the Harbor operator to make sure it has reasonable stability, reliability, and high performance. So that's something about the operator. Alex.
Thanks, Stephen. Yeah, this is incredible. We've been working on this for, what's it been, like 8 months at least? I think huge thanks to OVH Cloud, right? OVH Cloud putting in a lot of work here, and I think they're going to be using the operator very soon, right? Well, it's one of the reasons they wanted to have an operator deployment is because they're spinning up Harbor clusters on their paths. So I think for any other community members, if you're consuming Harbor in such a way that it's being managed as a platform service, this is a really incredible, a really powerful way to deploy it, to manage, right, all the things, all the benefits that Stephen just talked about. These are things that are not available to you as a Helm chart when deployed as a Helm chart that you can do now, and you can customize through the operator and have high availability across all these components. So, but I guess I would just mention that we would basically have the Harbor Helm deployment as well as the Harbor operator, and you can use Helm if you're targeting a smaller single cluster deployment, and you review the operator for more as a service. But it doesn't mean that we're stopping development or deprecating the Helm chart in any way. We're going to keep both. Helm is still incredibly popular. It's incredibly easy to just edit a bunch of values in the Helm chart. You can see the operator is much more complicated, right? And there's different ways to deploy it with these components without as a full stack or a thin stack. So both are options. Both are two ways to deploy as Kubernetes clusters that we're going to keep investing in. So any other questions for Stephen for the operator in general?
No question. Just a big shout out to the entire team and all the community members who have helped work on this and get it to a 1.0 status. This is fantastic to see.
Yeah, I mean, it's been pushed back a couple times. I think we were targeting for a release as early as December of last year, right? But it just didn't feel quite ready, and we didn't want to release it without it being fully validated. So something that has spanned to I think 3 minor releases, over 2 minor releases, so into the 3rd one. So a lot of work, a lot of contributors, but yeah, really nice.
Yeah, really a good job.
So that's everything we have planned for this meeting. Any other comments or questions? Didn't share, Jonas? I don't know if there's anything worth calling out. The attendees, maybe.
Sorry, what?
Sorry, I meant the attendees on KubeCon.
Yeah, so we had a ton of attendees for both the session that we had and the office hours. So I want to thank all the maintainers and everyone that showed up to the both the session and answering a ton of questions during the office hours. It was a lot of questions. We captured a lot of them in a HackMD that's been shared out to the community and to all maintainers as well. So hopefully we can follow up on a few of those. There were some feature requests. I hope some of those have been turned into issues already by the community members who asked them, but if not, then we can see what we can do. Yeah, it was just a fantastic showing to both the session and the office hours, and it was great to see. One more thing, and we'll talk more about this in June. But Orlin, who is who's going to be or who is the new community manager for Harbor, and me, we're working on a plan for setting up a working group for technical documentation for Harbor to kind of make sure that the technical documentation becomes a little more autonomous within the project. And we have a few already interested contributors who wants to be a part of this. So I'm gonna ramp things up in June. We'll launch it in June. We'll kind of revamp the office hours that we used to have, and make them into office hours for technical documentation first and foremost, to kind of get that working group up and running. We'll reuse the Harbor Dev mailing list to make sure that everyone's aware of the conversations that's happening, instead of creating a separate one. And because we don't have that much noise on the Harbor Dev anyway, so we'll reuse that one. Same thing with the Harbor Dev Slack channel. We'll reuse that one for that kind of conversation too. That's about it. Any questions, comments on that?
The North American office hours, are we changing the time, or are we keeping it?
No, yeah, so we're going to switch that out. So we have the community meetings at this time, and it makes sense to have the office hours at the same time. So we'll schedule the office hours on the reverse weeks, not the reverse, the opposite weeks. So today we have a community meeting. So in June we'll have office hours the week after the community. So we'll keep this time slot and use that for the office hours. That should hopefully capture a lot of contributors over in Asia and Europe as well, and help build that out.
Awesome, sounds good. Thank you.
So, Alex, do you want to give some heads up regarding 2.4? So if community member who has some proposal, please bring it to your attention so that we can plan accordingly.
Yeah, I mean, we're only really speaking to TNN here. Everyone else is a Harbor maintainer or a Harbor team member, but the 2.4 is, yeah, the 2.4 is being planned right now. So the 2.3 FC is this week, and then GA is going to be 2 weeks from now, 2 or 3 weeks from now. So we're trying to collect requirements for the 2.4. If you have anything, an existing issue or something else on your mind, please make sure it's have an issue created for it in 2.4, and you can ping us on Slack. You can ping me on Slack. You know, and we'll add it to the backlog and consider it for the 2.4 roadmap. So I think we're on track for you know, this is our second minor release, right, in June. And so 2.4 will go out this year as well. So we'll have 3 minor releases this year, which was our goal for this year. We only had 2 last year. So, but I think for 2.4, I have a bunch of issues. If I'm from GitHub, smaller issues, but a whole series of them. And then, I think we're making improvements to replication. There's a lot of work to be done in the operator still, as you can see. And yeah, day 2 management is a big theme. Okay. See if there are any other questions or comments. If not, we can just end in here. And welcome to the team, Orlin.
Thank you once again.
Welcome.
Thank you, folks.
All right, let's end it here. Thanks, everyone.
Go on, folks.
Great day.
Thank you. Bye.
Bye-bye.
Bye.